Okay, this is a continuation of the addition of hydrogen halides and water to alkenes. So here we have, here's the first example. We have ethylene plus hydrogen chloride. And as you can see, since both of the carbons on that double bond have the same amount of hydrogens bound to them, there's only one product. There's no major or minor product, just one, and that's chloroethane. So one of the carbons will take on that positive part, which is the hydrogen, and the other will take on the negative part, which is the chlorine. But it doesn't matter which one, I guess. And one thing I noticed about naming this, like the product, see, it's chloroethane. Ethane is C2H6. Now, this is C2H5, but since it's the next closest thing, that's the closest name you could give it, you call it chloroethane, even though it's not exactly ethane C2H6, it's C2H5Cl. Okay, so that's an example of a alkene being added, what's it called, a hydrogen halide being added to an alkene, and there only being one product since both of the carbons on the double bond have the same amount of hydrogens. Now here we have another example. So again, there's only one product. You have the hydrogen iodine right there. It's being added to, what's that, 1, 2, 3, 4. So that's butene, I guess. So the product is CH3, CH2, CH, and CH3. So since both of the carbons have the same amount of hydrogens bound to it, either one of them takes on the iodine, and the name of it is 2-iodobutane. So remember, there's 4 carbons in that product, and 4 carbons means butane. It's not butene because there's no double bonds, and 2 signifies the number of the carbon that has that iodine bound to it. Finally, the last example here, we have that 1, 2, 3. What's that? So it's propene being added to hydrogen bromide. Now we have 2 products here since one of the carbons only has 1 hydrogen bound to it and the other has 2 hydrogens bound to it. So this will have a major and a minor product. As you can see, the major product, the carbon on that propene that had the most hydrogens bound to it, that took on the positive part of the hydrogen bromide. And the minor product, you can see here, CH3, CH2, with the CH3, CH2, CH2 with the bromide right there. That's the minor product. So you just reverse this. See how this carbon that had only 1 hydrogen bound to it took on that negative part. This one, the carbon that had 2 hydrogens bound to it, that took on the negative one. So it's just the reverse, and that's the minor product, and that's called 1-bromo, bromo being the bromine, 1-bromopropane. And we say 1 because that's 1. It's the number of the carbon, 1. And this is 2-bromopropane. That's the number of the carbon 2. Now, maybe I drew this minor product incorrectly. Maybe I don't have to have that visible bond there. I could just put that Br on the side. But this one I know for sure I needed that visible bond because that bromine was landing in the middle of that equation. Let me check that. Yes, I was correct. This is drawn incorrectly. Should be CH3, CH2, CH2, B. BR. Excuse me, because I wrote that with my left hand. So there it is. We drew the 1-bromopropane, but you don't have to have that visible bond since that bromine is on the end, on the last carbon. So like it's not in the middle, jammed anywhere. Okay, so those are examples of hydrogen halides being added to alkenes. 3 examples. One where there's only one product, another where there's only one product, and the final example has 2 products, a major and a minor product. Okay.